Okay, so we're going to do more practice with elimination. Last time we did elimination, we wanted to, like, for example, we know that 5y and negative 5y eliminate each other. Because 5y negative 5y equals 0. Well, guess what? We're going to have to do some more multiplication. Instead of just multiplying by a negative, we might have to multiply by another number. So we're going to have to think about common numbers that we can use. So it says, what do you do if there are no matching coefficients? Well, you have to use distribution to get a pair of variables or variable terms to eliminate. Okay, so this is what I mean. Like, for example, x plus 2x is not going to equal 0. Neither will positive 3y plus negative 7y. And it wouldn't even work if I multiplied by negative 1. However, I love looking for plain x and y's. That makes my life so much easier. If this was a negative 2, it would be a negative 2x, and it would eliminate with the 2x. But I can't just randomly make that a 2x. I have to multiply both sides of the equation by 2, which means I have to multiply everything. Well, a little shortcut. When I'm sorry, negative 2. Oh, because the second equation is a positive 2. So then I get negative 2x minus 6y equals negative 12. Actually, you know what? I'm going to write it under the second equation just to save room. That way they're already lined up. So I have negative 2x, and negative 2 times 3y is negative 6y, and negative 2 times 6 is negative 12. Now I can go ahead and add straight down because the 2x and the negative 2x eliminate. Negative 7y and negative 6y, they combine to negative 13y, and negative 1 and negative 12 is negative 13. So we divide by negative 13, and y equals positive 1. So we have the first coordinate is positive 1. Now I just plug it into one of the equations. Well, guess what? I'd rather use the original first equation because it's smaller. So I'm going to use that and plug in x plus 3y, but we know y is 1, equals 6, or x plus 3 equals 6. Subtract 3, and x is going to equal 3. So then that's our first coordinate. Because remember, all of our answers are going to be x comma y, where the x comes the first coordinate and the y is the second coordinate. It doesn't matter which one is first or second. Okay. So again, we're always looking for variables that will eliminate. And if they don't, if there's no matching coefficients that will eliminate, we're going to use distribution. And my tip is look for 1y. So right away, I could care less about the x's. I want to eliminate the y's. But the only way the 3y will eliminate is if I have a negative 3y. So that automatically tells me I have to multiply the second equation on both sides by negative 3. So the new second equation, well, negative 3 times 2x is negative 6x, negative 3 times y, negative 3y, and negative 3 times 5 is negative 15. I'm just going to copy the second equation, or sorry, the first equation. So that's 9x plus 3y equals 12. Okay, now I already have, because I distributed negative 3, the negative 3y and the 3y eliminate. And then I just combine all the other terms. So negative 6x and 9x is 3x equals, well, negative 15 plus 12 is negative 3. Mental math, x is negative 1, so you divide by 3, x is negative 1. Well, since that's our first coordinate, that's our first coordinate in our answer. Okay, Now that I know x is -1, I'm going to use the original first equation. So before I multiplied by -3. So the 2x plus y equals 5, but the x is -1, so I get 2 times -1 plus y equals 5. Or -2 plus y equals 5, add 2 to both sides, and y equals 7. So the second coordinate is 7. Okay. So I'm going to finish the evens, but I want you to try the odds. I hope you're starting to get the idea. So like for number 4, it doesn't matter whether you want to eliminate the x's or the y's. I just always choose the smaller number because smaller numbers are always easier to work with. So I'd rather eliminate the y's because if I can make this top equation a positive 2y, it'll eliminate with the bottom equation negative 2y. But I can't just randomly put a 2, I've got to distribute. Okay, we've got to use the distribution property so it stays equivalent. So the first equation, I'm just going to write underneath, becomes 2x plus 2y equals -6, and I'm just going to use the bottom equation as the new top. It doesn't matter, just as long as they line up. See how the x's are lined up and then the y's, and then it equals the c's. Okay. Well, the beautiful thing is -2y and positive 2y eliminate. 5x and 2x is 7x, and -50 and -6 is -56. So then when you divide by 7, x equals -8. Okay. Now we just plug in. So again, on number 4, we found x is -8. And now we're going to plug that into one of the, I'm going to use the original top equation since it's the easy x plus y equals -3. So it's -8 plus y equals -3, add 8, and then y just equals positive 5. Boom. So remember, it does not matter whether you eliminate the x's or the y's, but I always choose the smaller variable. Just like if I ever see there's a 1x or a 1y, that's the one I use to distribute so I can use smaller numbers. All right, so let's look at number 6. Well, again, I automatically noticed the 1y. If that 1y was a -2y, it would eliminate with the second equation. So I'm going to multiply everything by -2 to distribute. So my new first equation is -6x minus 2y equals -4. Well, right away, and the reason why I draw this line is so I'm going to use the second equation and the new first after I distribute. Right away, all of these are going to eliminate. Well, anything that eliminates, it equals 0, and I'm left with 0 equals 0. Well, anytime the variables eliminate, either you're going to get a true or a false statement. Well, this is true, so the answer is infinite solutions. So in fact, these would be parallel lines. Okay. Now look at number 8. There's going to be some equations where it's not enough to multiply one equation. You're going to have to multiply both. Like the 3x and the 5x. There's no whole number or integer that I multiply by to get -5. So, same thing with, there's no integer to multiply by 3 to get 4, and we don't want to deal with fractions. That's yucky. We don't want to deal with it. So, one thing you could do is say, okay, well, what do they have in common? Like 3 and 5 have 15, or 3 and 4 have 12. So you either want to get -15 and a positive 15, or you want a -12 and a positive 12. You just have to choose which equation you want to be the positive and which equation you want to be the negative. Well, I'm just going to go with the smaller numbers. They're not that much different. But I'm going to do the y's, which they have, I want this one to be, I don't know, let's make that the -3y, or 12y. So I have to multiply the top equation by -4. And then I want this one to be the positive 12, so I'm going to multiply that by 3. So the top equation becomes negative 12x minus 12y, and then negative 4 times 9 is negative 36. You have to make sure you multiply by everything or it's not going to be equal. And the bottom equation you have to multiply by 3. So you get 15x plus 12y, and then 3 times 10 is 30. So now I'm going to go ahead and add straight down because I have my negative 12y and my positive 12y. That's why I multiplied one of the equations by a negative and one of them by a positive, so I get opposites. So then negative 12x plus 15x is 3x, and negative 36 plus 30 is negative 6. So you divide by 3, and you find that x is negative 2. So the first variable we found on number 8 is negative 2. Now, I'm just going to use the original top equation to plug it in to find the y. So I'm going to get, instead of 3x, 3 times negative 2 plus 3y equals 9, because that was the original first equation. So negative 6 plus 3y equals 9. Add 6. So then 3y equals, well, 9 plus 6 is 15. Divide by 3, and y equals 5. I kind of ran out of space there. Okay. Now look at number 10. It doesn't matter whether I want to eliminate the x's or the y's, but there's nothing I can multiply by 2 to get 7, or there's nothing I multiply the 5 by to get 7 unless it's a fraction, and I don't want to deal with fractions. So I'm going to choose the x's, and 7 and negative 2 have a positive 14 and a negative 14 in common. Well, since one of them's already positive and one of them's already negative, I'm going to multiply the top equation by positive 2 and the bottom equation by positive 7. Because if you already have one positive and one negative, you don't need to change the signs. So we just multiply by positives to keep the signs. So we distribute that, and you get 14x plus 10y equals negative 26. And then we get negative 14x minus 49y equals, well, 7 times 26 is, let me get my calculator. Is 182. So if you notice, now our x terms will eliminate. So the 14x and the negative 14x eliminate. 10y and negative 49y, well, that's going to give us a negative 39y. And then I'm going to use my calculator, and basically 182 minus 26, because there's more positives, equals 156. Then we divide by negative 39. And you get y equals negative 4. Okay, so let's plug in negative 4 for y. It doesn't really matter. I'm going to use the top equation before I multiply by 2. I'm just going to use this space. So I have 7x plus 5 times negative 4 equals negative 13, because again, I plugged it into the original top equation before I multiply by 2. So I have 7x minus 20 equals negative 13, add 20, and 7x equals 7. Divide by 7, and x equals 1. So then the x goes in the first coordinate for our answer. Okay, number 12. So I hope you're starting to get the idea of you're trying to find coefficients that will eliminate, and you might have to distribute different numbers for both equations. Because, like, I would automatically choose the smaller numbers, 5x and 7x, I know they both have 35 in common, but I want one to be a negative 35 and one to be a positive 35, and it doesn't matter. So if I multiply the top equation by negative 7, I would have to multiply the bottom equation by positive 5, so after I distribute, I get one negative 35 and one positive 35. So just to save room, okay, the top equation, when I distribute negative 7, I get negative 35x, and negative 7 times 9 is negative 63y, and negative 7 times negative 10 is 70. Now I distribute the 5 in the second equation, so 5 times 7 is 35, and 5 times 10 is 50y, and 5 times negative 1 is negative 5. Okay, I'm just gonna kind of box this off so you, okay. Now, just as a little warning, these may seem like a lot of work, but I promise you, you're gonna miss Algebra 1 when you get into Algebra 2 because this is considered to be minimal work, like not very much work compared to some of the problems you're gonna see in Algebra 2. So now we can combine the equations because the negative 35x combined with 35x eliminates. Negative 63y plus 50y is negative 13y, and 70 and negative 5 is 65. Now if I divide by negative 13, I get y equals negative, well, let's see, I think it's negative 5. Just want to check. Yep, it's negative 5. So on number 12, our y is negative 5, so you got to make sure you put it, because remember, all of our answers are x comma y. You got to make sure the y goes in the second coordinate, even though we found the y first. It doesn't matter which one comes first. In the solving, the y always comes second. Okay, now let's plug it in. It doesn't matter which equation. I'm just going to use the top equation. So I have 5x plus 9 times negative 5 equals negative 10. So that's 5x minus 45 equals negative 10. Add 45, and we get 5x equals 35, and you divide by 5, and x equals 7. So now we know the x-coordinate of the answer for number 12 is 7. Okay, so go ahead and try the odds for 3, 5, 7, 9, and 11. I'll put the answer key to see if you understand it, then I will work those out at the end of the video. Okay, so the thing I really need you to understand, it doesn't matter whether you multiply to eliminate the x's or multiply to eliminate the y's. I'm just trying to show you tips on what's going to be the least amount of work. And anytime you can minimize your work, you can always minimize your margin for error, or basically your possibility of errors. Right away, see this negative 1y? And we have a positive 4y. If this was a negative 4y, they would eliminate. Well, that just tells me I need to multiply by positive 4 because I already have the negative. If there's already a negative there, you don't need a negative, unless both of them were negative, but that's a different story. That's another example. So if we multiply everything in the first equation by 4, I get 12x minus 4y equals, well, 4 times 14 is 40 plus 16, which is 56. You add straight down, well, 5x and 12x is 17x. 4y and negative 4y eliminate, and that was the whole point of multiplying the first equation by 4. And then 12 plus 56 is going to be 68. Divide by 17, well, get my trusty calculator. So 68 divided by 17 is 4. So that means x is 4, just like the answer key says. Now we know the y is negative 2, so it doesn't matter which equation. I'm going to use the original first equation without the 4 being distributed. So I have 3x, we know the x is 4. So it's 3 times 4 minus y equals 14. So that's 12 minus y equals 14. Subtract the 12. So negative y equals 2. Mental math, or divide by negative 1. We found out y is negative 2, which is what the answer key says. Now, as soon as I see that negative y, I also recognize, okay, the other equation has a negative 3y, but 2 negatives isn't going to work, so I'm going to have to multiply the bottom by a negative. In fact, I'm going to multiply by negative 3, because when I multiply by negative 3 times negative y, I get a positive 3y. And I know that the positive 3y will eliminate with the first equation. So the new second equation becomes negative 6x, negative 3 times negative y is positive 3y, equals negative 3 times negative 5 is positive 15. So I'm going to copy the first equation. The original first equation was 3x minus 3y equals negative 3. So when I combine them, negative 6x and 3x is negative 3x. The positive 3y and the negative 3y eliminate. 15 and negative 3 is positive 12. So I'm going to divide by negative 3, and x equals negative 4, just like the answer key. Now I'm going to choose my original bottom equation to plug in the x. So I get 2 times negative 4, minus y equals negative 5. So I get negative 8 minus y equals negative 5. Add 8, and you have negative y equals 3, divide by negative 1, and y equals negative 3, which is what the answer key says. Okay, so for number 7, automatically my eye is drawn to the 4y and the 8y because I can multiply the 4y by negative 2 and get a negative 8, which will eliminate with the positive 8y. If I did the x's, I'd have to distribute both equations, and there's nothing wrong with that. I'm just trying to teach you how to recognize to do the least amount of work. So I would multiply the top equation by negative 2, because when I distribute that, that's how I get the negative 8y that will eliminate with the other equation's 8y. So when I distribute, the new top equation becomes negative 6x minus 8y equals negative 12. And then I just draw this line so I know that I'm going to be combining the second equation with the new first. 7x and negative 6x is 1x, or just x. 8y and negative 8y eliminate. 10 and negative 12 is negative 2, and I don't have to divide, and I find the x. Ooh, did I make a mistake? Unless the answer key is wrong. All right, let's check. Oh, my goodness. I'm getting tired. So 10 and negative 12 is negative 2. Oh my goodness. Okay, now that matches. Holy cow. All right, now I'm going to multiply or plug in that negative 2 to the original top equation, because that's just the easier one. So instead of 3x, it's going to be 3 times negative 2 plus 4y equals 6. So that's negative 6 plus 4y equals 6. Add the 6 to both sides. So I get 4y equals 12, divide by 4, and that's where y equals 3, just like the answer key. All right. So, oh, you've got to be kidding me.